We are giving a diagram of Tim's walk to the park. On the y-axis we have the distance in meters. On the x-axis we have the time it takes for Tim to go to the park. This time is given in minutes. The first question asks us to figure out how long it takes for Tim to get to the park. For this we need to carefully inspect the graph. We can see that the graph is divided into three distinct parts. We can think of the first part as the walk from home to the park. This is between 0 and 1 minutes. The distance increases from 0 to 60 meters. This means that it takes 1 minute for Tim to get to the park. Question B, we can see that the distance remains constant, which means that Tim stays in the same place, in the park. This is happening from minute 1 to minute 6. So if we just subtract 1 minute from minute 6, we find out that Tim spends 5 minutes in the park. The last part of the graph shows Tim's return home. We can see that the distance is decreasing from 60 meters to 0 meters. When the distance is 0 meters, it means that Tim has returned back home. So now we can calculate the time it takes for Tim to get back home. He has travelled from minute 6 to minute 9, which means that he has travelled for 3 minutes till he gets back home. Now we have to calculate Tim's average speed. In order to do this, we need to know his speed for each of the three parts. Now we can ignore the middle part because his speed was 0, as he was staying in the same place. We know that speed is distance over time, so we can therefore calculate the speed in the first part and the speed in the second part, and then just average them to get the final speed.